Welcome back. Today we are going to address LeetCode problem 771 as you see here using Java code. It is to identify the number of jewels in a given bunch of stones. Let's go through the problem statement. You are given strings jewels representing the type of stones that are jewels and stones representing the stones that we have. Each character in stone is a type of stone you have. You want to know how many stones are jewels, and it's case sensitive as you see here. So an example one is bunch of jewels here. You need to identify if these jewels are available in this set of stones. Likewise, there's an example two. We'll implement this using Java coding right away.
We are now going to solve LeetCode problem 771, which is to identify jewels in given bunch of stones. What does it exactly mean? So consider a use case where we have stones as in characters like this: A, B, C, D, and so on. Of all the stones that we have here, all of them are not precious. Only few of them, A, D, C, as you see here, are considered precious and they are referred to as jewels. So we have bunch of stones and then we have bunch of jewels. We need to identify how many stones over here are regarded as jewels. That's our goal. For this, we are going to use HashSet. Now, if you're wondering what HashSet is, I'll give you a small background. HashSet is a set interface implementation, which is a collection of non-duplicate elements. Meaning, if you create a HashSet for stone, then you're going to have non-duplicate elements. Only one instance of A, whereas there are multiple instances of smaller case A you see here. Likewise, a single instance of B is going to be available in the hash set, even though there are multiple instances of B in the entire set. So it's going to be unique non-duplicate elements, and it's fundamentally built on foundations of hash table. In this problem, we're going to use the package HashSet to import hash functions. And the set of functions supported by HashSet are like this: add, remove, size, content. So we're going to use some of them here, but not all of them. And with this basic background of using HashSet for this implementation and about the problem statement, we start coding.
We are going to compute the number of jewels in the stones. So for that we have a counter. We simply say jewel count and we initialize that with 0. This is going to be number of jewels in the set of stones. And then here we have jewels in form of strings and then stones are also in form of strings. We'll pull all of stones and jewels and insert them into a hash set. For that, we'll create a hash set of type character. We call it as jewel set. New hash set angle brackets. So we initialize the jewel set hash. Okay. Now we go ahead and add all the jewels to the set. So for every jewel in the string jewels that you see here, need to convert them into a character array. Go and insert it into the jewel set table. So jewel is a character out of the string that comes out of jewels. We take that one by one and insert it into the jewel set hash set here. Okay, so next we check if each jewel is available in the stone set, or the other way around, if each stone is a jewel. Likewise, we convert the stones string also to character array, and now as we iterate over the stone strings, we identify or compare to see if the jewel set contains this stone. If it contains, then we increment our jewel count. That's it. Now return the jewel count. We have integer value that's expected, which is jewel count. We are done with the implementation. Now, as usual, before we continue with execution, we'll perform sanity check. This needs to be uppercase. Okay, all good. So check the number of test cases available here. There are two test cases. We have jewels here, which is smaller case here and uppercase here. Two jewels, and the stones are like this. So it matches with small a, big A, and uppercase A again. So we got expected result should be here 3. So remember, we are creating a hash set for jewel, and there is no hash set for stones. So we're going to iterate over all the stones across the jewel set. So for each stone that we encounter here, which matches with the jewel, we're going to increment the jewel count. So essentially it's going to be 3. Here there's a difference in the case here. So though it's Z, we have a lowercase z categorized as jewel and uppercase z as stones are available. So the result should be 0. Let's run. Okay, fine, as expected. That's good. We are done. Thanks for watching. You've been so far hearing from Vidya. If you like the kind of videos that I'm making, consider subscribing.